Okay, I've had enough.
What? Amy, come back. I don't know how to open the oysters.
So, were you turned on even a little bit?
It was like being hit on by Rat Pack Pee Wee Herman.
Bill Prady, co-creator of The Big Bang Theory, recently revealed the reasoning behind the long-standing broken elevator in the show. Since the pilot episode, the characters have been forced to use the stairs due to the malfunctioning elevator. Prady explained that this was a deliberate choice to foster more interactions between characters, which helped develop stronger bonds both on-screen and with the audience. He cited his previous work on Dharma and Greg as inspiration, where characters frequently interacted in an outdoor space. The decision to have the characters use the stairs in The Big Bang Theory served a similar purpose, encouraging more dynamic and engaging scenes. The mystery behind the broken elevator in The Big Bang Theory is finally revealed. Bill Prady, co-creator of The Big Bang Theory, revealed why the elevator in the series is broken and why it was never fixed over 12 seasons. Since the pilot episode of The Big Bang Theory, the characters in the series have had to take the stairs because the building's elevator is broken. Co-creator of the sitcom, Bill Prady, revealed why the elevator was never fixed. During a participation at WonderCon, Prady explained that the absence of the elevator and the frequent use of the stairs in the set allowed the characters to interact more with each other, creating a stronger connection and bond with the audience. When Chuck Lorre and I worked on Dharma and Greg, we had an outdoor set where the characters could talk. And we used this because it was an available space in the 20th Century Fox studio where we were filming Dharma, he said. The co-creator said he tried to apply the same technique in The Big Bang Theory, but the set took up too much space. What if they always had to take the stairs? Prady thought along with Lorre. In the sitcom The Big Bang Theory, characters Leonard and Sheldon, two physicists, share an apartment and are neighbors to Penny, an aspiring actress. The series delves into funny everyday events with various scientific and pop culture-related facts. Japanese researchers first spotted the balls in 2021, but it is only now that telescope observations have confirmed just how strange they are. According to this new study, the light coming from these distant objects doesn't fit with anything predicted by current theories about star formation. Although they resemble dense clouds of gas or newly forming stars, they are totally isolated from regions where stars normally form. Likewise, even though they give out infrared light as a star would, this doesn't line up with the large amounts of ice that surround them. To make things even stranger, the only two examples ever found are located extremely close to one another in the sky. Lead researcher Dr. Takashi Shimonishi, of Niigata University in Japan, says, "We tried our best to reproduce the properties, but currently we cannot find any theories that can explain the spectral energy properties." When Dr. Shimonishi first spotted the two icy balls, it was immediately clear that they were exceptionally odd. The objects were spotted using the Japanese Akari Space Telescope, which scanned the Milky Way in the infrared spectrum between 2006 and 2011. This revealed that although the objects were close together in the sky, they were actually far enough apart to be unrelated. Dr. Shimonishi and his colleagues estimated that Object 1 is about 9.3 kiloparsecs, 30,332 light-years, from the Sun in a region of the Milky Way called the Crux Scutamarm. Object 2, meanwhile, is 13.4 kiloparsecs, 43,704 light-years, from the Sun in the Carina Sagittarius arm. Although Dr. Shimonishi's initial observations suggested that these objects were unusual, the Space Telescope didn't have the resolution needed to reveal more. Now, the researchers have used the Atacama Large Millimeter/Submillimeter Array, ALMA, in Chile to look again in the hope of resolving this mystery. And even with the help of the largest telescope in existence, these two icy orbs still don't look anything like any other object in the universe. If anything, this new set of measurements only raised more questions. The ALMA observations show that the balls are somewhere between 1 and 10 times the size of our solar system. Although that might seem vast, this makes the objects relatively small compared to other gas clouds. Additionally, the wavelengths of light escaping the objects suggest that they are composed of carbon monoxide and silicon dioxide. The fact that there's a lot of silicon compared to the amount of carbon is what you would expect to find where a young star is violently blasting out new material. However, Dr. Shimonishi says that the object's small size, high ice content, and isolation don't match any other type of star known to science. For this reason, the researchers suggest that they may have found a previously unknown type of object. Professor Jane Greaves, an astronomer from the University of Cardiff who was not involved in the study, told New Scientist, "It's a fascinating piece of work, albeit rather puzzling." The two objects seem to have contradictory characteristics, being cold enough to have abundant ice, but also infrared emission like a star. Our Shimonishi and his co-authors have now applied to use the James Webb Space Telescope, JWST, to gather new data about these strange objects. Those observations could help settle the question of whether these icy balls fit within our current theories of star formation or not. Dr. Shimonishi says, JWST is very sensitive and has a high spectral resolution, so we can do a very detailed analysis of ice or dust, which can help us understand the thermal history of the source. Stars form from dense molecular clouds of dust and gas in regions of interstellar space known as stellar nurseries. A single molecular cloud, which primarily contains hydrogen atoms, can be thousands of times the mass of the Sun. They undergo turbulent motion with the gas and dust moving over time, disturbing the atoms and molecules, causing some regions to have more matter than other parts. If enough gas and dust come together in one area, then it begins to collapse under the weight of its own gravity. As it begins to collapse, it slowly gets hotter and expands outwards, taking in more of the surrounding gas and dust. At this point, when the region is about 900 billion miles across, it becomes a prestellar core and the starting process of becoming a star. Then, over the next 50,000 years, this will contract 92 billion miles across to become the inner core of a star. The excess material is ejected out towards the poles of the star and a disk of gas and dust is formed around the star, forming a protostar. This matter is then either incorporated into the star or expelled out into a wider disk that will lead to the formation of planets, moons, comets and asteroids. Our story picks up a bit after the events of the first season of The Night Agent, and our hero, Peter Sutherland, Gabriel Basso, is on an important mission. Peter looks a little different. To start the season he's got a beard, and almost all of our characters from last season, even Rose Larkin, Peter's charge and eventual love interest, are gone. We're a little disoriented, and that's the point. But there's one familiar face. Despite the fact we've never seen her before, Alice, Peter's new night agent partner, should look familiar to just about everyone watching at home. That's because she's played by actress Brittany Snow, who for the last 20 years has been appearing in all sorts of popular shows and movies. We don't know Alice, but Beck.